Let's do a review on dynamic memory, allocating it, especially when a class is involved. So here's code about a chair class, and it just has one private member variable that's an integer number of legs, and another private member variable that's an array of doubles, and that's going to hold the chair's latest three prices, selling prices. And that array is of size 3. So in our code, we are just declaring all of that right here. Pretty straightforward. That is a dynamically allocated array. And then let's look at our two constructors. So the default constructor first. No big surprises there, except note that in the private member variable section where we declare this pointer called prices, pointer to an array, that doesn't allocate any memory. There's no new keyword as part of that line 10 statement. Instead, the new declaration comes at line 14, and that's when the allocation occurs, and there's a pointer to it named prices. Then, of course, we set our legs to 0 by default, and then we step through that prices array and set those to 0 as well. Now, then the parameter constructor has just got the one variable, the number of legs, and we kind of do the same thing, except we set the number of legs to L instead of to 0, and we still step through the prices array and initialize all of those to 0. Normal setters and getters here. No surprises there, except we have set prices, and that's going to accept 3 doubles and just simply populate the 3 array elements with those values. Now, in one of the labs, you'll have to change this such that it doesn't receive 3 separate doubles, but instead receives a list of doubles, an array of doubles. Now, this is important, and I highlight this in the in our lesson page for this video, and that is the average prices. Let's talk about that. We could easily have a private member variable that's named average, but we wouldn't want to ever do that. And that's because that variable could easily become stale with stale data. Stale data is data that is no longer updated. So for example, if we had an average and we calculated it and stored it into average, but then let's say down here the prices change again, well, now our prices are different and our average doesn't reflect the true average of those different prices. We'd have to make sure that there's a lot of glue and a lot of coding. Instead, what developers tend to do is just have a single get method for that, and the calculation occurs immediately and it's returned. So that's what that function is doing. And again, it avoids the instance of stale data. And here's an easy print function, just going to step through that array. And then take a note here, in our main function, we're going to code these chair objects 3 different ways. The first is just simply by making a pointer to a chair object. So in main, here's just an object, and there's our pointer to it. And since we have a pointer to it, we can then call its setters, its getters, etc. So that's what happens in section 1 there. Now section 2 is going to do something a little different. It's going to still create an object in main and a pointer to it, except we're going to use the different constructor, the parameter constructor. We're going to send the value 3 to it, and that's the number of legs that it gets. Then the third way here is that we are creating an array, in this case, a dynamic array of chair objects. Then we go kind of one by one through those 3 elements in the array, and we call the setters for those to populate that data. We could easily just do that randomly in the constructor so that we wouldn't have to do all of these setters. And matter of fact, that will be the subject of one of your labs this week. So hope this helps as a good review just of what this dynamic memory process is and the pointers involved in that.